Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, I am going to help you solve literal equations. And I'm going to do that by working through 26 different examples. So what I did is I pulled out some different types of ways that you might see literal equations. We looked at some formulas as well as some linear equations and also like some rational equations that you can see. So there's a lot of different ways that literal equations, show up, and you can see what we're going to do is we're going to work on solving for different variables, because I feel like when students are doing literal equations, they sometimes understand one example and then we do something else and they get completely lost. So hopefully through these 26 examples, after you've gone through this video with me, you'll feel a lot more comfortable to be able to solve your problem on your own. So the main idea, again, for literal equations here is that we're going to have one or more variable. So therefore, that's why for each example, I'm telling you what variable I want you to solve for. So therefore, in this equation, I want you to solve for y. In this occasion, I want you to solve for w. But you can see here, let's actually start with number 2, because that makes a little bit more sense. Or it's a little bit easier to kind of work with. And then I'll kind of work with 1. I'm not sure why I made that 1, because that's a little bit more of an advanced problem. All right, so let's go ahead and actually, you know what? I'm just going to kind of skip ahead to some of these probably easier ones. So let's go ahead and work on number 2 here. Not sure how this order came about. So if I want to solve for w, we have 2 other variables, right? We have p and l. We don't know what p and l represent, nor do we know what w is, but we know we need to solve for w. And again, if we want to solve for something, for w, that means we want our final answer to be w equals, right? We basically want w to be isolated by itself, alone, right? And we want the coefficient of w to be a positive 1. So you can see right now, w on the right-hand side is not by itself, right? There is a 2l, as well as it's being multiplied by 2. Now, sometimes it's understanding like, well, what is actually that 2l doing to it? And, it's important for us to understand if you were to swap these around, you would do 2w plus 2l, because that's really a positive 2l, right? That's not a negative. There's no subtraction sign or a negative symbol in front of it. So that's a positive. So therefore, it'd be 2w plus 2l. Just like if I said 2 plus 3, you could also write that as 3 plus 2, right? So the main idea here is we need to solve for this by using our inverse operations. So in this case, I'm going to write this in. So I'm just going to switch this around. You don't need to do this once you get good at it, but I want you to be able to visualize and see, not really visualize, but I want you to concretely see what is actually happening to the w. The w right now is being added by 2l. So therefore, I need to undo adding 2l. So I'm going to subtract a 2l. So I can't subtract 2l from p, so that's going to be p minus 2l. Is equal to a 2w. So again, we're using our inverse operations as well as the reverse order of operations. And now I need to undo multiplying by 2, so I'm just going to divide by 2. Okay? So therefore, my final answer is, I'll write it like this. So we can write this as p minus 2l divided by 2 equals w, right? Or we could switch this around. We could also write this as w equals, divide the 2 over there, and then minus the 2 into the negative 2l. And that's another way that you guys could, see the answer. I'm going to skip over number 3 again and number 4. Let's go ahead and do number 5. Again, you can see here we have this y. What's happening? Well, again, this y is being added by 10x and it's being multiplied by 5. So first we want to undo the addition or subtraction of the variable. Since it's being added by 10x, I'm going to subtract a 10x. Again, you cannot subtract 10x from 80. So it's going to be a 5y equals 80 minus 10x, and now let's just divide by 5. Okay, so we have y is equal to, and we could just leave it in this format, or you could divide that 5 into both of them. So 5 goes into 5, 10, and that would be 13. 5 goes into 30, no, that would be 16, I'm sorry. So that would be 16 minus 2x. So you could just leave that. Here, let me just write this. Let me just write it a little bit since we have a little bit more. Obviously, we want to simplify this, so I'll just write this in. This would be 80 over 5 minus 10x over 5. And then you could simplify that to 16 minus 2x. So again, we're solving for y is equal to 16 minus 2x. So therefore, hopefully you can see again, we're solving for y, and you can see y is being isolated. This next one, a is not isolated, so I'm not really sure where a was supposed to be. I guess maybe I was supposed to do b. So let's just do that. So in this case, we have b. If I wanted to solve for b, again, you can see that b is being added by the x. So let's just go ahead and subtract the x on both sides. These are not in order of difficulty for obvious reasons here. So therefore you can say this is c minus x, fairly simple. I'm not sure what was supposed to be here. That's supposed to be a big C, I believe, circumference equals 2 pi r. Okay, so now in this case, we have, r is being multiplied by 2 pi. So therefore, to undo multiplication by 2 pi, I'm just going to divide by a 2 pi on both sides. So if I just divide by 2 pi, again, I can't do anything really with their circumference. So circumference divided by 2 pi is just going to leave me circumference divided by 2 pi is equal to r, or we can just rewrite that with the r first, which would be c, sorry, I'm using circumference because I'm going off of the formula, divided by 2 pi. All right, so here's another example. Now you can see we have a negative in this case, which is perfectly fine. But we just need to understand that instead of, we're not subtracting by 5, we're just multiplying by a negative 5. So in this case, we still have this positive 3x, so I need to subtract the 3x. And notice I've done that a lot of times, right? I did these examples a lot because they trick up a lot of students. They don't see that positive 3x. They don't see that as adding to your variable y, which again, we're trying to isolate the y in this case. So they don't see that as an adding 3x or adding a 3x, so you got to subtract. And again, we want to subtract before we undo multiplication and division. So in this case, we have a negative 5y is equal to a 9 minus 3x. And now in this case, I'm going to divide by a negative 5, right? Because now I'm multiplying by a negative 5. It's interesting here that this negative 5 does not divide into that evenly. So we can just rewrite this, as this fraction here. Or we could split it up like I've done before and divide the negative 5 into both of those terms. Actually, for this one, let's just do that one more time. So that'd be a negative 9/5 plus 3/5 x. And you could also rearrange those, right? If you wanted in slope-intercept form, you could put the 3/5 x in front of that. All right, let's go ahead and get into the next example here, number 9, solve for y. Now you can see it's pretty explicitly shown that we're adding a 4 to the y, so therefore I'm going to subtract a 4. So therefore I'm left with 5x minus 4 is equal to a negative 4y, and then I'll just divide by a negative 4. Okay, and again, if we want to distribute this now to kind of pick things up, because I'm doing 26 examples, I'm going to distribute that negative 4 to both of those, so I have this in slope-intercept form, which is typically like our preferred version here, and then negative 4 divided by negative 4 is going to be a positive 1. Okay, so I flip the equations for y and then distribute it. Here's another one, solving for y, so let's add that 7 here. So then I have 4x plus 7 equals 3y. Again, divide by 3, and I'm going to go ahead and flip them. So in this case, I have y. Oh, so this is my first one subtracting. Yeah, so you can see, again, if you're adding 4, you use the inverse operation, which is subtract. And remember to do it on both sides. Here, I'm subtracting by 7, so I'm going to add a 7 on both sides. And then, again, I'm multiplying by 3, so I'm going to divide by 3. That cannot be simplified, so I'm just going to leave that as a 4/3 x plus 7/3. All right, now we have the variable back on the left-hand side. You can see how, things can go either way. And now we have, okay, so I'm going to need to subtract the 7y and then divide by 2. So let's subtract the 7y in this case. So I have 2x is equal to 4 minus 7y. So now it's not going to be in slope-intercept form, right? But that's fine. Divide by 2. 2 divides into 4, but not to the 7. So therefore, x is equal to a 2 minus 7/2 y. I'll come back to this one. I want to do all the ones that only have like the one variable first. So I'm going to do kind of the basic ones here first. So I'll come back to those. All right, so for this next one here, I'm just solving for x. So again, now we're seeing we're multiplying by a fraction. So something new, right? So let's just get the 12 to the other side because we're kind of familiar with that. And this got all arranged. So y plus 12 is equal to a 2/3 x. Okay, so now what do we do? How do we get rid of this fraction? Well, again, it's the same thing. Like, how'd you get rid of multiplying by 2? You divide it by 2. So if you're multiplying by 2/3, then divide by 2/3, right? I mean, it's nothing crazy, something you haven't learned. But the thing is, you got to remember, well, if you're dividing by a fraction, what is that the same thing as? And remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So when I So I'm dividing by 2/3, right? And that's what we did before. You did take this term, you divide it into both of them. Well, remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So I can actually rewrite this problem like this. No, 3, yeah, divided by 3/2, right? Okay, so it's very important for you to understand when you divide by a fraction, you're multiplying by reciprocal. Again, that's going to take your coefficient to 1, which we want, right? Because 2/3 times 3/2 gives us 1, and therefore our fraction is going to be isolated. We don't typically use a parentheses around this. We just kind of understand that that 2 divides into both of those terms when it's separated by addition or subtraction. But a key mistake that students will make in a problem like this is when they multiply an expression, that's separated by addition or subtraction, they don't use parentheses. And what they do is they'll just write this as like 3/2 y, and then plus 12, and without the parentheses. And you got to remember, you got to use those parentheses, because if you don't use those parentheses, what's going to happen is you're not going to apply distributive property. So in this case, we're going to have 3/2 y, and then here 3/2 times 12. You can basically just divide the 2 into the 12, which gives you 6, which would give you a positive 18 is equal to x. And then you could rearrange that with the x first if you wanted to, or we'll just leave it just like that. So let's go ahead and get into some more. Oops, still got some more problems here. All right, so I'm gonna skip the fraction ones here for a second. This one's actually not a bad one though. So no, let's just come back to it. Okay, so this one, now we're kind of going back to a formula, right? And now we have a, b, x, t, and c, and we're solving for x. So we have all these variables, but we need to solve for the variable in the middle. Well, just remember, 3 times 4 times 5 is the same thing as 5 times 3 times 4, right? The order doesn't matter. So if I don't like the x in the middle, then I'm just going to rewrite this expression. A is equal to, let's just do bt x plus c. Okay. Now, if anything, you've kind of followed the process that we've dealt with so far. We will first want to undo addition and subtraction, right? That's the reverse order of operations. And we use our inverse operations and the properties of equality, right? So we use inverse operations of addition, which is subtraction. We use the property of equality. Whatever we do on one side, we're going to do on the other side. And now you can see my x is being multiplied not only by t, but also by b. It's being multiplied by both of them, right? So here's the 4. You can recognize this 4 is being multiplied by 5 and a 3. So yeah, you could divide by 3, and then divide by 5. Or you could divide by t and then divide by b. But why don't we just divide by both of them at the same time to save us some trouble? All right, so that's going to divide out, and that's going to leave me with x equals a minus c divided by bt. And I'm just going to leave it just like that as the simplified version. All right, so now we have another equation another kind of linear equation, which is x and y's. We want to solve for y. So again, we can see that we haven't added 2x. So I'll just add the 2x over there. Then we have 2y is equal to 5 plus 2x. Divide by 2, divide by 2. Let's put this in slope-intercept form. Y is equal to 2 over 2, which is just x, plus 5/2. I'll skip the fraction here for a second. Let's do this one. I like this one because basically we need to divide out where this h here is being multiplied by an r. It's being multiplied by pi, as well as being multiplied by 1/3. So therefore, we need to divide this example. We need to divide by 1/3 pi r, right? That's everything that's being multiplied by h. So 1/3 pi and r. Now again, dividing by 1/3 is the same thing as multiplying by the reciprocal. So the reciprocal of 1/3 is going to be multiplying by 3. Okay, so therefore, I can rewrite this as, let's see how would be the best way to rewrite this so it doesn't look totally confusing. So I do v, so I'm going to multiply it by 3 and then divide it by pi and r is equal to 3 pi r, 1/3 pi r divided by pi and r. Okay, so instead of dividing by 1/3 on both sides, I'm going to multiply by 3. Multiplying by the reciprocal is the same thing as dividing by the fraction. And therefore, what happens here is obviously those to go to 1, those divide out, and we're just left with our h. So therefore, if I write the h first, I'm going to have 3v divided by pi r. There we go. Next one is a lovely slope-intercept form. So if I just want to solve for the x here, I'll subtract the b, do that first. Y minus b is equal to mx. And then to solve for x, I'll just divide by m here on both sides. So x is equal to y minus b divided by m. Nice one, parentheses. I'll come back to those. D equals r times t, solve for r. So again, you can see that r is being multiplied by t. So I'll just divide by t here on both sides. So r is equal to d divided by t. G here, this one looks a little confusing, right? We have some squares, we have 2 t's going on, like, but again, you're just solving for g. So again, like, identify what is happening to the g. Again, you can see that the g is being added by vt. So to get the vt to the other side, or get it off of that side, I'm just going to subtract by vt. So I have h minus vt is equal to a negative g t squared. All right, so now you can see that my g is being multiplied by actually 2 numbers, or 2 values. It's being multiplied by t squared, as well as being multiplied by a -1, right? That's minus, it's a negative gt squared, not minus, it's negative gt squared. So if I want to solve for g, I'm just going to divide by a negative t squared. The negatives will divide out, the t squareds divide out, that will just leave me g all by itself, negative t squared. So in this case, g will be h minus vt all over a negative t squared. All right, number 23 here, I. So again, this one looks really confusing, right? But again, identify your I. Sometimes I used to do this when I taught. I would just say, guys, take the I and pin it, right? Just like put a circle around it. Now we just need to identify everything that's happening to that and then undo it. So right now we can see the I is being multiplied by 1/2, it's being multiplied by w squared, and it's being added by u. So when using your reverse order of operations, we need to first undo addition and subtraction. So I have e minus u equals, now again, let's rearrange this. Let's rearrange this to 1/2 w squared I. Okay, now I'm basically just going to divide by 1/2 w squared, divide by 1/2 w squared. Now again, I already kind of told you that dividing by 1/2 is the same thing as multiplying by reciprocal, which in this case is b multiplying by 2. So really, this can be rewritten like this, e minus u all over w squared. Okay, and you can distribute the w to both terms, and you can distribute the 2 to both terms, right? It doesn't really matter, how you want to do it, or how your teacher or professor, asks for it to be done. There's many different ways that we could write this. And so usually I just like to show students these different ways for, like, if they're doing a multiple choice test or anything like that, they have like some different variations of what's going on. 24 is going to be solving for D. Now this one, yeah, I'll come to that one in a second. We'll do that one later, or last. All right, the last one is H. Okay, I'll do this one. So a lot looks like this going on here, right? You can see we have this whole expression and we have this, and then there's our nice little h. So when you actually kind of step away though from this problem, you recognize here that the h is being multiplied by 2 pi r, and then it's being added by 2 pi r squared. So even though it's a lot to kind of digest in your brain, it's really nothing different than what we've already been doing. It's being added by a number, so adding by some quantity, so therefore we need to subtract that quantity on both sides using the inverse operations. So therefore we have a minus 2 pi I r squared is equal to 2 pi r h. So now we need to undo multiplying by 2 pi r, so I'm going to divide by 2 pi r on both sides. And therefore I have h is equal to a minus 2 pi r squared divided by 2 pi r. Whew, lot to digest. Okay, so let's go ahead and get into, I think we need to do the factoring out here first, and then I'll go ahead and approach, let's do the parentheses first, and then we'll approach the rational expressions. And I only have, looks like only two of them with the factoring. Okay, so let's go and take a look at this one, which I want to do. This one's solving for a. All right, I like this problem. So in this case, if you have parentheses, I can't like undo, I can't like subtract an x because it's, following your order of operations. If you were to like expand this, you would have to get rid of the parentheses. You'd have to distribute that 2 first. So what we need to do is, before we can isolate this a, we need to get rid of these parentheses. So to get rid of the parentheses, I need to distribute that 2a. Or the 2, I'm sorry. So when I distribute that, I now have a 2x plus a 2a equals 4b. All right, so now I just need to subtract that 2x to the other side. 2a is equal to let's do 4b minus 2x. And now I can't combine those, right? They're not like terms. And now I can divide by that 2. So therefore, a is going to equal, let's see, 2b minus x. Okay, so just remember, if you add parentheses, you got to make sure you basically distribute to get rid of them. And that's going to be something that's going to come up again in a little bit more advanced problems. Now, what about this problem? Because whatever you do, if you're going to solve for this x, then you're going to need to subtract that x to the other side. Then you're going to have x's on both sides. If you're going to solve for this x, you're going to subtract nx to the other side. So therefore, then, either way, whatever you do, you're going to have x's on both sides. So how do we get rid of these x's? Well, in this case, we're actually going to want to create parentheses. And we're going to create parentheses by factoring out the x. So when we factor out an x, we get x equals n plus n equals p. But it's very important for you to understand what I did in this process. I had 2 variables on one side. When you're solving, you can't have the variable on the other side, right? So what I'm doing is, by factoring out, I am actually now combining these 2 x's into one term. This is still the same expression. If you distribute that x into both terms, you're still going to get the same expression, right? So now I see that my x is being multiplied by 1 plus n, or x times 1 plus n, right? So to solve for this, I just need to divide by the quantity, or the expression 1 plus n. So I had x is equal to p over 1 plus n. And there you go. All right, so let's go and get into the fraction portion of it. Now, again, we've kind of dealt with some fractions here. Now we're just going to be dealing with some expressions. So, however, there is a couple like trains of thought here. We've already done this many times. We took fractions, right? Or took, something like this, and we distributed it to both of them. So one way you could solve these problems, if you don't like what another technique I'm going to show you, you can just always take this value and distribute it into both of them. I'm not going to do it this way, but there's nothing wrong with distributing 3 into both of those terms and then now solving. It's like, boom, then you're basically done, right? Well, not done, but now you know to subtract a 1/3 and then multiply by 3/2, right, to solve for d. Or the other way you can kind of think about this is, here's my quantity d. It's being multiplied by 2. It's being added by 1. And the expression in the numerator is all being divided by 3. So if basically, another way you can do it is just kind of think about, how do I get rid of fractions? If you don't like this fraction, right? So you could distribute that, but you're still going to have fractions. And I think for most students, they just would prefer to do math without the fractions. So my advice to them is, well, then get the fraction to be reciprocal, right? Basically, what you need to do is, if you're multiplying by, you can think about this by multiplying by like 1/3 on the top and bottom, but that's not going to work. Well, it would work, but it's just going to make everything a little bit more confusing. You get the same idea. So what I would prefer to do is, well, what if you multiply by 3? What if you undid dividing by 3? Oops, crap. Stop. What if we used our inverse operations here? Instead of, see, here's my d. Instead of dividing by 3, what if I just use my inverse operations to multiply by 3? Then I have a 3c is equal to, those 3's would now divide out to give me 2d plus 1. Well, now I have an expression with no fraction. So even though this one works and it makes sense, I think for a lot of students, they would prefer just to deal with problems that, do not have variables, or fractions. And then I'm just going to flip the d around. So d is equal to 3c over 2 minus 1/2. Okay, so a lot of times when we have fractions, that is something that is, helpful for students. So let's go and look at another problem here where maybe I have like an x in the denominator, right? So instead of dividing the x into both of them, because if you did that, you'd still have x in the denominator. So you can see how like that fraction answer doesn't really help me out here, right? If I divide this x, like now I still need to get x off the bottom. So to get x off the bottom, eventually I'm going to have to multiply by an x on both sides. So when I multiply by an x on both sides, I'm just going to be left with a 3 minus y is equal to 5x. And again, if I'm just solving for x, all I need to do is now divide by 5 on both sides. So this would be 3, let's just write the x in front. So therefore, x is equal to a 3 minus y over 5. And there you go. And here's another example, again, where we have the y in the denominator. So if we want to solve for x, now this one's kind of important. Like we want to get rid of this y, so let's just multiply by the y on both sides. So now those divide out. So therefore, I'm just going to be left with an x plus 2. I'm sorry. 2y, subtract 2, subtract 2. X is equal to a 2y minus 2. Let's see here. Next example, is that the other ones? Let's keep on doing this. Let's go ahead and solve this one for y. Now this one, so we solve for y here, or solve for x, I'm sorry, and it was in the numerator. Well, what if I wanted to solve for y? So in this example, again, what we need to do now is get this y off the denominator. If you're trying to solve for something, it needs to be off the denominator. So I'm going to multiply by a y on both sides. That's going to get that y off the denominator on the left-hand side, right? So now I'm just equal to 2y, and then I can just divide by 2. So, it wasn't a very difficult problem, but it wasn't really a good problem to start off as example number 1, or at least on this worksheet. I wanted you guys to be a little bit more familiar with, solving for the reciprocal before we got into that. Question number 13 here is solve for x. All x is doing is just being divided by a. And again, that's really the same thing. You could also rewrite this as 1 over a times x, right, is y over b. Like it doesn't really matter if it's divided by a or multiplied by a reciprocal. So you're just going to multiply by a on both sides. So therefore, x is equal to, y times a over b. All right, so now let's get into the fun ones here. It's number 3 and question number 4. So number 3 here is, fortunately we have x, but we have x's on both sides, right? And we have some fractions. So the main thing I'm going to want to do is get rid of these 5 and the 2 in the denominator. So to do that, I'm just going to multiply by a number that 5 and 2 both divide into them. Because if 5 divides into that number, you're not going to have, any remainder here. So what do 5 and 2 both have in common? Well, in this case, they both have a 10 in common. So I'm going to multiply everything by 10. So 5 divides into 10 2 times. So that's going to be a 3x plus 2y is equal to, and then if I multiply by here, that 2 goes in there, that's a 5 times. So 5 times 4x minus 7y. All right, so basically by multiplying by the 10, 10 divided by 5 2 times. When I multiply 10 here, 2 divides into 10 5 times. All right, so now I can apply my distributive property, right, because we want to get rid of those parentheses. So therefore, by getting rid of my parentheses here, I get 6x plus 4y equals 20x minus 35y. All right, so now, again, to solve for x, I got to get the x's to the same side. So I'm going to subtract a x on both sides, or subtract a 20x, and then I'm going to subtract a 4y on both sides. So what that gives me now is 6 minus a 20x is going to be a negative 14x. That goes to 0. That's going to give me a negative 39y. All right, so I'm going to have to redo this because I ran out of space. So negative 14x equals a negative 39y. Now, to solve for x, I'll just divide by 14. 14 does, or negative 14, I'm sorry. So that's going to turn that into a positive. So now x is equal to a 39 over 14y. Doesn't look like a very nice answer. Negative over negative makes it positive, but hopefully at least you can see that, getting rid of my fractions, or when you have variables on the same side, you get them here, and then get rid of any parentheses that you might have created, and therefore can combine your like terms. All right, last but not least here, I have multiple variables I have multiples in the numerator and the denominator. So, one of the things that I wanted you to kind of see is, some of you might say, oh, cross multiply, the cross product. And yeah, if you are familiar with the basic understanding of what I just did, you can see that basically, by doing it that way, I'm really just multiplying each denominator, right? Or each numerator by the other denominator, right? Which we call like the cross product. So when you have a proportion, which is a ratio equal to another ratio, you can apply the cross product. And typically it is a easier set, rather than trying to always figure out what the common denominator is and stuff like that. The problem with applying the cross product is a lot of students forget why they're doing the cross product, and they start to not apply it correctly. So hopefully though, we're going to go under the assumption that you could find the LCD here, which would be 2x minus y. You multiply everything there and you get to this point, or just by applying the cross product here. So again, we have the same thing. We're going to distribute that 2. So therefore I have a 2x plus 2y equals a 3x minus 3y. And now again, I just need the x's to the same side. I recognize in this case though, I'm going to get the x's to the left side. Again, I'm just going to use my inverse operations here because I want to solve for x. So therefore that's going to give me a 5y is equal to a positive x, or x is equal to a 5y. So you can see that you can work on this, when you have parentheses, when they can be helpful. Obviously, sometimes, when they can be sometimes when we need to use them to go ahead and factor out terms, and so on and so forth from there. That was a fraction. Those you can go ahead and lock like terms. So there we go, ladies and gentlemen. Hopefully, I think I covered everything for you. All right, there you go. So hopefully working through these 20 examples, you feel a little bit better about solving linear equations. Hope it's been helpful, but if you had any kind of questions on any of these types of problems, or at least the thought process that I worked through, please feel free to add in any comments down below, and I'll be more than happy to see what I can do to help you out. See you guys on the next video. Cheers.